Hello everyone, my name is Abhishek and welcome back to my channel. Today is day 18 of AWS DevOps Zero to Hero series, and in this video we will learn about the concept of cloud cost optimization. So this video is going to be both theory and demonstration video. As part of demo, we will do a project using which I'll explain you how DevOps and cloud engineers, basically this is for both DevOps and cloud engineers, and how they are going to use this project in a organization. So we will understand how this is used in real time, the cloud optimization project. And let me tell you that this is a very important project, and most of the DevOps engineers use the cost optimization on a day-to-day basis. Now, why is it that? Okay, so why is that most of the organization use this? In previous videos, I have told you multiple times that there are two primary reasons why organizations move towards cloud, right? The reason one why people move towards the cloud is to reduce the overhead of the infrastructure. And the second thing is to optimize their cloud cost. I mean, you can just say to optimize the infrastructure cost. What does that mean? Let's say there is a startup, or let's say there is a mid-scale organization. For these companies, the process of setting up the entire data center, then purchasing the servers, arranging those servers, and maintaining an entire team. You can call them as a data center team, you can call them as system administrator team, whatever that is. So building this entire setup, the data center setup, the server setup, and continuously this team has to monitor this data center, right? So if the data center is not monitored, then it will cause a lot of issues, like there can be latency, there can be loss of data, there can be servers that are going down. So in a nutshell, that overhead for the startups or for mid-scale organizations is that they have to create this entire setup by themselves and they have to manage a team. Now this is not just an overhead, but if you watch it carefully, or if you think of it carefully, setting up the entire data center, purchasing all of these servers for lifetime access, then paying out for all of these engineers. So it's going to be a big amount for the startups, right? Or even for mid-scale organizations. So that's why for them, a easy go-to solution is cloud. And this is something that I've explained you on the first classes itself, right? In the first classes itself, I've explained you what is the difference between public cloud and private cloud, and why people like the startups and mid-scale organizations show interest towards the public cloud. This is something that we have discussed. So in today's video, I will explain you this second aspect, that is the cost optimization aspect. Now you might be thinking that Abhishek, why you or why DevOps engineers need to perform some activities related to cost optimization. I can simply move from, let's say this is a data center, the on-premises data center, right? For startups, instead of setting up this on-premises data center, I can simply onboard on cloud platforms like you have the AWS, because this series is entirely about AWS. Let's talk about AWS only. So you might say that as a startup and as a DevOps engineer in the startup, I can just suggest my organization that instead of going towards the culture of building this entire data centers and everything, simply move towards a cloud platform and my job is done. You can say that, right? But this is a wrong thing, because after moving to cloud, the cost, right, the cloud cost will go down only if you are doing this efficiently. Now what does it mean? Why I'm saying that the cloud cost only goes if you use efficiently? Let me give you a very basic example. So let's say there is a developer, sorry, just a second. Let's say there is a developer here. Okay, you have granted this developer proper IAM access, and the IAM access is that this developer can create an EC2 instance. Okay, so now this developer has good knowledge of cloud, so he went ahead and he created his own EC2 instance on the cloud platform. And what he has done is he has attached a volume to this EC2 instance, or by default when you create an EC2 instance, there is a volume attached to it, right? Without volume, you cannot store data inside the EC2 instance. Let's say you want to create some files, you want to update some configurations and stuff like that. So this developer has created the EC2 instance, and he has started populating the volume. And what he has done, he or she, basically the volume is filled with the information that is very sensitive for the organization, or they just want to take the backup of the volume. So what this person has done, he has taken backup each and every day. Okay, so taking backup volumes is nothing but this person has started taking the snapshots. Okay, so in this technology terms we call it as snapshots. If you take a snapshot of a volume, that means you have technically taken a backup of the volume. So each and every day this person has started taking the snapshots. Right now, after a while, what has happened is, this person said that, okay, this feature is deprecated. No, I don't want this, so let me delete the EC2 instance. It is of no more useful. And this person went ahead and, let's say, has deleted the volume as well. Okay, has deleted the volume as well. Or for example, he was using some external volume. So like, just say that this person has created additional volume for the EC2 instance and deleted the EC2 instance but forgot to delete the volume. Now, if the volume itself is forgotten to delete, of course, the snapshots that this person has taken each and every day will also be forgotten and they will not be deleted. And AWS will keep charging you for all these snapshots and all these volumes. So this is just one basic example. You can think of this as like there are endless options, right? For example, there can be S3 buckets that are created by some developer, and probably that developer stopped using the S3 buckets, but he has forgotten to delete the S3 bucket. And the content in the S3 bucket, right? When you keep updating the content in the S3 bucket, eventually AWS charge will go significantly high, right? Or let's say this person has created a EKS cluster and forgotten to delete the EKS cluster. So there are 200 resources on AWS, and manually monitoring these 200 resources to verify if someone has created some stale resources. Let's call this as stale resources, which is an appropriate word, right? So what is stale resources? Stale resources is something someone has created but forgotten to delete those resources. So that way, the cloud cost will go high than you expected if you are not doing the cost efficiently, right? If you are not managing the cost of the cloud platform efficiently, then what would happen? The cloud cost will go high, right? Now, what is that means for an organization? So organization has moved to cloud platform, assuming their cost will go high, but assuming their cost will go down, but it is actually going high. So this is one of the primary responsibilities of DevOps engineer, right? So DevOps engineer should make sure that the cloud cost should go down. And how DevOps engineer can ensure that? By looking at if there are any stale resources on the cloud platform, right? If there are any stale resources, then a DevOps engineer can typically do two things. One is DevOps engineer can send out the notifications saying that, hey, I have noticed that you have created a EBS volume, but it is not attached to any EC2 instance, or you have created bunch of snapshots and these snapshots are not attached to any volume or any EC2 instance. So why don't you delete them? Or if this DevOps engineer has access or has permissions to delete them, which is in general cases, DevOps engineer would have that access. So you can go ahead and also delete the instances, right? Who can delete the instance? So DevOps engineers can also go ahead and delete the instances. So there are two possibilities. And in today's video, we will explore the second option, because sending of the notifications using SNS topics is something that we have seen in the past in this series. So let's focus on understanding how DevOps engineers can implement the cost optimization, right? How DevOps engineers can implement the cost optimization using the delete option. That means by deleting the stale resources. So the architecture here is very, very simple. I'll start with the basic architecture and I'll explain you this in a very, very simple way. We will use Lambda functions. Okay. Sorry. Yeah. So we will be using Lambda functions, and inside this Lambda functions, we will write Python code, which is quite general for DevOps engineers. DevOps engineers usually write the code in Python for the Lambda functions, because many DevOps engineers are familiar with Python compared to the other options like Node.js or Go language, other options which Lambda functions support. So you will write Python code in the Lambda functions. We will use a module in the Python code called Boto3. Okay. So what this will do is it will talk to the AWS APIs. Let's say you want to, like, you will not write one simple or one single Lambda function for each and everything on the AWS, but you will write Lambda functions individually. That means you will write a Lambda function, for example, for EBS snapshots that we were talking about. Okay, for EBS snapshots, you can write a Lambda function, and this Python code that you have written will talk to the AWS API, and it will get the complete information of the EBS snapshots. If there are stale snapshots or if there are active snapshots, I mean, if some volume is actually using the snapshots, or that volume is already deleted, or that volume is not attached to EC2 instance, then you can delete those snapshots using the same Lambda function. And because Lambda functions are usually event driven, you can also attach this Lambda function, or you can trigger this Lambda function using a CloudWatch. So now let me explain this in a very, very better way so that you can also explain the interviewer. I've written the notes for this as well. So you can also refer to the GitHub link in the description where I've written the project notes, how to explain this to the interviewer, and the code entirely is also available on GitHub. So you can follow me and you can also perform this project on your personal AWS account. So the architecture goes something like this. Firstly, you have Lambda function. And what is the problem statement? The problem statement is that there are some EBS volume snapshots. Okay, so this developer has an EC2 instance, let's say, and for this EC2 instance, the developer uses a volume. This can be an inbuilt volume or a volume that that comes with the EC2 instance. And for this volume, the developer has created multiple snapshots because he felt that the information is important. Later, the developer has deleted the volume and deleted the EC2 instance, or just deleted the EC2 instance, you know, and these snapshots and volumes were not deleted. Any case one is just the EC2 instance is deleted, or case two is EC2 instance and volume both are deleted. In any of the case, these snapshots are useless, right? Because the snapshot makes sense if the snapshot is available for a volume that is attached to an instance. But if not, these snapshots are available for a long time and nobody is using it. So it would be better to delete those snapshots. Perfect. So EBS volume snapshots, this is the problem statement. And what you would do is basically you would write a Lambda function. And this function is written just as I mentioned, it is written in Python code. Sorry. Yeah, so it is written in Python code. Just a second, this stopped working. Perfect. And this will talk to the AWS API. Step one would be to fetch all the EBS snapshots. And step two would be to filter out. Okay, to filter out the snapshots that are stale. And once we identify this one, we will just delete the snapshot. Okay, so once we identify that, just proceed and delete the snapshot. And this is the exact same project that I'm going to demonstrate. And don't worry if you are not aware of this entire concept, and if you are new to it, if you just follow the video along with me, I have the entire code that is available for you. The description is also available for you. Step by step, I'll walk you through the code and you can perform the demonstration with me. And you can add this to your resume because this is one of the day-to-day activities. So without wasting any time, let's quickly go to the demonstration. And yeah, let me share the other screen. Okay, so now I have logged into my AWS account. You might be thinking like, Abhishek, I have a question. Now, what if, going back to the example that you have stated, let's say I have intentionally created some snapshots. I have deleted the volumes, I have deleted the EC2 instance, but I kept those snapshots just for backup purpose. You might be thinking in that way. Yes, that is quite possible, but you need to understand that even in such cases, what you can simply do is you can verify the timestamp, like what is today's date and when was that snapshot created. You can give a buffer time, let's say that for 6 months, if this snapshot is not used, then just delete it. So when was the snapshot last used and what is the current date? But let's not make it that complicated, right? So it is just a if condition. You can add it anytime. But in today's video, let's try the demonstration that if the snapshot is created and if it is not attached to any volume, or if it is attached to a volume but that volume is not attached to an EC2 instance, right? In both the cases, the snapshot has to be deleted. So let's try that part. So perfect. So what I've done, like I just mentioned, you can go to my github.com and you can just go to a folder called Day-18. So if you go to this folder called Day-18, I have added the README document. This is exactly the problem statement, and you can explain this same problem statement to the interviewer without any hesitation. If you are a fresher or if you are a college graduate, you can add this project as is in your resume as well. Or if you are an experienced person, you can add it as a point in your resume. Perfect. So now you also have the code available here. You can just go to this folder called ebstail snapshots.py. So this is the code that is available as well. Don't worry, I'll walk you through the code, but just for someone who wants to practice from their end first, and once they get the confidence, they want to learn the code, that is also fine. You have the entire code that is available here. Now, firstly, let me implement this and then I'll explain you the code structure, right? So that things will be clear. So I'll go here, I'll click on Lambda. Okay. And before this, what I need to do is I need to create a EBS volume snapshot. Go to the EC2 dashboard, and within the EC2 dashboard, now let's create a EC2 instance. Okay. Firstly, we'll create an EC2 instance and we will create a snapshot from the volume of the EC2 instance. I hope you all understood the concept of snapshot. It is very, very simple. You can just understand it as a copy of the image. So let's call it as a test EC2 instance. Just provide the name as Ubuntu. T2 micro is fine. AWS login is also good. I don't want to change any parameters. See, by default, there is a volume that is getting attached. If you want, you can add additional volume, but we are fine with this volume. Okay. So create launch instance. Perfect. Now the instance is launched, and with the instance comes a volume. So let's wait for the instance to be up and running. Meanwhile, if you go to the EC2 dashboard, you should be seeing a volume that is getting, see, there are two volumes. One volume will be the volume of the instance. Okay. So this is something that I already have on my account. So let me just delete the volume. Perfect. So this is the volume that is getting created along with the EC2 instance. Let's see if the instance is in running state. Perfect. Instance is in running state. If you go to the instance, there is this volume available here. Storage. See, this is the volume. It ends with 45E, right? So we can search for that. Go to the EC2 dashboard and go to the volumes. See, this is the one, 45E. Now, what this developer has done is each and every day he started taking the snapshots of this. So go back to the EC2 dashboard. You have some section called snapshots. Create snapshot. So he's just taking the copy of this volume. That's it, because he has some information. you can just assume it as an image of the volume. So next, if after 1 year, if they want another volume or if they want to copy this data, they can simply spin out the volume out of the snapshot. Okay. So I'm creating a snapshot. Let's call it as test snapshot. Create the snapshot. Perfect. Now the snapshot is also created. The snapshot status is pending, but it got created. Now what this person has done is, after a while, he actually want to delete the instance, want to delete the volume, and also want to delete the snapshot. Okay. But this person has forgotten. Okay. So this person forgot that the snapshot should also be deleted. He has some hundreds of snapshots, but he forgot to delete all the snapshots. He just delete the instance, automatically the volume got deleted, but snapshot stayed back. Okay. So in such case, we will use this lambda function, right? So we are going to write now a lambda function that will help to do this activity for us. So I'll keep the instance as is. Firstly, we will write lambda function, and I'll show you that it does not delete snapshots which are attached to volumes, right? That are attached to EC2 instances. I mean, we will see that it will not delete snapshot that belongs to a volume, and that volume is assigned to EC2 instance. Right now we are in that state, right? So this EC2 instance has this volume, and this volume is taken as a snapshot, right? So let's go to the lambda function, create a lambda function called cost optimization EBS snapshot. Let's say Python. We will go with the default permissions, and I'll update the permissions later, right? So this function will fail couple of times. I'll tell you the reasons. So firstly, let's go to our GitHub page and copy this entire code. Okay, I've copied the code. Now go back here, scroll down, remove this, just paste the code here. And what you will do after that, save this, click on the deploy button, press Ctrl S, deploy, click on the deploy button, and then click on the test project. Just give the event name as test and save it, because you are manually triggering the event, right? You are manually invoking it. If you are invoking it through CloudWatch or something, you don't have to create the test event. So click on the test button, and now it will fail because by default lambda functions execution is only 3 seconds, and it is also failing for some permissions issue. Okay, it is saying that the describe snapshots permission, or that role which is running this EC2 lambda function, does not have permissions to describe the snapshots. Perfect, because what I'm doing, I'm describing all the snapshots and I'm filtering out the stale snapshots. Okay, we will give that permissions, but before that, let's go to the configuration tab and edit, increase the default invocation time to 10 seconds. So if someone asks you what is the default invocation cost time for lambda, sorry, not invocation, default execution time for lambda is 3 seconds, but you can increase it as your wish. Save it. It is better to keep the execution time as small as possible, because AWS will charge you using this as a parameter. Like the lambda execution time is also one of the parameter for charging. Okay, so make sure that you keep this time as less as possible. And while doing this project, let me tell you that if you don't delete this entire setup, or if you don't delete the EBS snapshots or volumes that you are creating as part of this project, it will incur costs. So please delete the instances. Now you can go here, go to the code. Yeah, so the other thing is we have to grant permissions, right? So to grant the permissions, we need to know what is the role that is executing this lambda function. So if you scrolled, if you have followed the previous videos, you will know what is a role. Usually when one service tries to talk to the other service, that happens through an IAM role in AWS. Okay, so go to the configuration button again, and here you have general configuration. Where is it? not triggers, environments, asynchronous syncs, test. Sorry, I lost the track of it. It is usually available somewhere here. No worries. Let's take a look at it. Permissions. Yeah. So this is the role, execution role. Click on it, go to the new tab. Now add the permissions to it, right? So what permissions are we going to add? We are going to give it describe snapshots and delete the snapshots. This is the default permission. Now click on the add permissions button. Click on attach policies. So if you just search for snapshots here, you'll not find anything because that snapshot thing that we are doing, it is not part of any of these default things, and it is also difficult to find. So what you can simply do is you can create policy by yourself. Okay, it is much easier to create the policy. So what I'll do here is I'll come here and I'll say the role as EC2, sorry, the service as EC2. And here let's filter the actions. Okay, what kind of actions do we want to perform? All actions on EC2? No. Or you can just say here snapshot. So here you will get all the options here, right? One is describe snapshots attributes, right? Writing permissions, permission management permission. So what exactly do you want to do? So I want delete snapshot permission. I want permissions to list all the snapshots. So that is describe snapshots. I think that should be enough. Describe snapshot and delete snapshot. I'm not doing anything more than that. Let's see if there is something that we are missing. I'll come back and I'll update the permissions. Resources should be all resources, right? Click on the next button. Now just give the name of the policy. Cost optimization, EBS. Create policy. Did I miss something? Yes. So now the policy is created. Now what we need to do is we have to go back to that role and we have to attach that policy, right? We just created a new policy. So again, if I go back to this, click on this button. Now only let me attach the created policy to it. Add permissions, attach policy, cost optimization, EBS. This is the one, right? Add permissions. Perfect. I hope, yeah, policy was successfully attached to the role. Now let's try to execute the role. Now what is the expected behavior? It should not delete anything because the snapshot is attached to a volume. I mean, snapshot belongs to a volume that is attached to an EC2 instance. Test it. I'm expecting, it said unauthorized calling describe instances. Perfect, because we are also describing the EC2 instances, right? We are trying to see that this snapshot belongs to a volume that belongs to EC2 instances. So we need describe instances. We also need describe volumes, right? So, I mean, I will explain you the entire code. For now, firstly, I want to show you the execution result. You will understand what is happening. Then I'll do the code walkthrough. So let's grant describe instances and describe volumes as well. If you are less patient, you can give complete EC2 instance permissions. But basically, we want to do the least privilege or the least zero privilege approach. So now what I can do is search for EC2 here or create policy like last time, and you can grant this EC2 full access, or yeah, let's do the policy thing because people will learn from the video. Let's take a couple of minutes more. Right. Again, go to EC2, just say list. What are we trying to do? Describe volume. Describe volume. So this is describe volumes. And then we also have to describe EC2. describe instances, right? So where is that describe instances? Yes, it's here. So this way, usually you need to grant the permissions. Click on the next button. Now if it fails again, don't worry, we will come back and we will attach. So I just want people to learn the thing. EC2 permissions. Let me just provide that. Okay. Create policy. Click on create policy. The policy is created. Now go back to the role. This is the one, right? And now let's attach one more permission to it. Attach policies EC2. What was the role I just said? EC2. Just okay. Let me refresh the page. Probably the information is not cached, right? So now let's try it one more time. Attach policy EC2. Yeah, EC2 permissions. This is the one that I've created, right? Add permissions. So if you feel that the information is not reflecting, wait for a while and just refresh it. You will get that thing. Now let's perform one more time. And if it fails again, don't worry, I'm here only. Now the script got executed. Congratulations, we have increased the Lambda function's timeout and we have granted the permissions. Now the script got executed. But you will notice that the snapshot will not be deleted. Okay, I'm going to show you that. Search for EC2. See, the snapshot is still here. Now what I'm going to do is I'm going to delete this instance. Okay, that instance will delete the volume as well. Terminate the instance. Okay, so the instance is shutting down. As soon as the instance will go down, the volume will also be deleted. Okay, and parallelly what you can do is, you can also create one more volume and you can also create one more snapshot out of the volume. Okay, so you can try out multiple things on this project, but let's go step by step and let me explain the code. Then it is all up to you. You can play with the project. You can create multiple instances, multiple snapshots, try out multiple scenarios by yourself. You just need to understand the concept. I hope it is done. Let's refresh and see. Perfect. Instance is deleted, volume is deleted, and snapshot is still there. Let me refresh the page and show you. Snapshot is still available. Now, usually within the organizations, so you can also add one more if condition here to the code. What that if condition would look like, instead of just directly deleting it, you can verify when was this snapshot previously used, or you can just send out a notification asking the team, hey, can you tell me if I can delete the snapshot. But let's assume that they have given you that 30 days threshold. They tell you that, okay, if the snapshot is 30 days old, you can delete it. Or if the snapshot was lastly used 30 days ago, you can delete it. So we can just add that if condition. It does not take much time. But now let's go to our project and give the test again. This time I'm expecting our code to delete the snapshot as well. See, it said deleted the EBS snapshot as it's associated with a volume that was not found. And that was our aim, right? If the snapshot is not associated to a volume, if the volume itself is deleted, now I will consider this snapshot as a stale snapshot and I'll delete it. In your organization, or when you explain to the interviewer, you can also tell that we will also verify the timestamp, and if the snapshot was used 30 days ago, we will delete it. Or you can say it as is as well. There is no problem. So let's go back to the snapshot and see if got deleted. Perfect. Now the snapshot is deleted. So this is the way how you can manage the cloud cost optimization in your AWS accounts as a DevOps and cloud engineer. Now this is just one snapshot. You can perform this demo, like you can use the same example, create 100 snapshots here, and all the 100 snapshots will be deleted in one single go. Similarly, you will write Lambda functions for S3 buckets. You will write Lambda functions for RDS instances, EKS instances, whatever you would like to in your organization, right? So if you want one more example, let me quickly show you one more example. Go to EC2 dashboard, go to volumes, create volume. Do not create with 100 GB, just create volume with 1 GB, right? Volume is created. Go back to the EC2 dashboard, go to the snapshots, create snapshot here. What is the volume ID? There will be only one volume. You don't have to worry it, because in my account, I just deleted everything. So there is only one volume that which got just created. Create the snapshot. Perfect. Now I have one volume, I have one snapshot. And now let's see how will this project behave. Test it. Right? The project got executed. I clicked on the test button. Now if you go to the dashboard and click on the refresh page, the snapshot is 0, but the volume is still there. Why? What is the reason? Because I have written this in such a way that if the snapshot belongs to a volume that is not attached to any EC2 instance, then delete the snapshot. Now this requirement might vary in your organization. From organization to organization, it depends, right? So you can add some if conditions, you can add some block conditions, but the fundamental principle that we have demonstrated here is if the snapshot is stale, if it belongs to volume that is not attached to any EC2 instance, just go ahead and delete it. It's up to your requirement. Now let me explain you the code, because I've given you the walkthrough of the demonstration. Final part that is left is I'll explain you the code. So what I've done here is I am using the Python code and I'm using a module called Boto3. Boto3 documentation is very, very good. All that you need to do is you can just write steps of what you want to perform, write it in plain English on a note paper or on a notepad. Then just go to the Boto3 documentation. Okay, search for Boto3. And these days you can make use of the chat GPT and other things as well for such programs. Now what I'm going to do here is I will search step by step. First thing what I want to do, right? So in this entire thing, the examples that I've performed, what I want to do is I want to list all the snapshots. I want to list all the volumes. I want to list all the EC2 instance, right? And once I list all of these things, now my thing would be to verify if this snapshot belongs to a volume and if that volume is attached to any existing EC2 instance or not, or running state EC2 instance or not. So firstly, what I've done here is I got the code for all the running EC2 instances. Okay, so how did I do that? I just went to the Boto3 documentation, just search for Boto3 EC2. So you'll go to the Boto3 EC2 documentation. Here you can search for different options for EC2 and you'll get the code ready. For example, I wanted to describe the EC2 instances, right? So I'll just search describe instances, go there, and here you have the syntax, right? This syntax will not be 100% correct. I mean, you have to modify it according to your examples. So what I've done is I've taken this syntax and I have put that in the program. Okay, and these days, like I told you, you can take help of ChatGPT as well. But I just said EC2, like I created the Boto3 client. This is the Boto3 module that I've imported if you know Python. And inside this, I created a client for EC2, and using that client, which will talk to the AWS EC2 API, I'm getting all the EC2 snapshots. Oh, sorry, this was the one. Ignore this statement for now. So using this EC2, what I did is EC2.describe instances. That means I'm getting all the instances that are in running state. Perfect. Now, once I have this, once I have the instances or EC2 instance information, now I am just getting the instance ID, right? What did I get here? I just got the entire JSON of the EC2. If you go here, you will also find that information. When you search for the Boto3 module, they have the request syntax and they also have the response as well. So what are you going to get as a response when you execute that? You are getting this entire information of all the EC2 instances. But I just want the EC2 instance ID. So there you need to understand how to parse the JSONs. So you need little Python knowledge here. Because this is not a Python class, I'm not going to deep dive into it. But here what I'm going to do is I'm going to use a for loop on all the EC2 instances JSON, and I'm just going to get the instance ID. So this active instance ID is a set data type that I've created, and I'm storing this in the active instance ID set. Similarly, I got all the snapshots information and I've got the volumes information. Okay. Once I have that, this is the exact logic that I have described. Okay. So what I'm doing, once I have the snapshot information, I'm verifying if that snapshot has a volume ID or not in the JSON format of the snapshot. Then if it does not have any volume ID, then I'm deleting the snapshot. Let's say if it has a volume ID that is attached to it, or if it belongs to a volume, then I'm verifying if the volume still exists or not, right? If someone has deleted the volume or if it is available. If the volume does not exist still, then using the try catch condition, or in Python we say try except. Using the try except, I'm handling the situation and I'm deleting the snapshots again, right? Both the cases I'm handling here. Volume is deleted or volume is present and it is not attached to the EC2 instance. Now in your organization, if the request is slightly different, if the requirement is slightly different, because there is no standard procedure for every organization. In some organization, they keep the snapshots like that. Okay, they just take the snapshots and they put that in the S3 Glacier. Okay, so if the snapshots are available, 100 snapshots, 1000 snapshots, instead of just deleting them, they'll create a S3 bucket, and inside the S3 Glacier, which is a Glacier Deep Archive, which is a cheap S3 lifecycle, they'll just go there and store the snapshots. Some organization would delete the snapshots, right? It depends upon the organization to organization. We took one scenario and I've explained you the entire thing, right? So this is how you use the AWS Lambda functions. But one thing that is left is, I told you in the last class that Lambda functions are event driven in nature. But here I was running this Lambda functions manually. So it's again up to you. If you want to run them manually, then you can create a test event and run it. Or else, we have our friend, which is CloudWatch. So you can go to CloudWatch and you can invoke this using CloudWatch. You can just tell that invoke it once every day, or you can say that invoke it once a week. You can say whatever you would like to, right? So you can go to the CloudWatch and here you have events. In the events, you can just say rules and you can configure the Lambda function as an event, or you can run it manually. So it's up to you. So last time I have invoked a EBS volume check, which we have done in our channel only. So what you will do, I haven't deleted it. It is available from last time, but simple it is. Just create a rule. What is the name of the rule that you want? Let's say EBS snapshots rule. Provide any description. And instead of running with an event pattern, you can run it on a specific schedule, right? Continue with the event bridge scheduler. That means this CloudWatch is creating an event bridge between CloudWatch and Lambda function. So here you can say, when exactly do you want to schedule? And once you click on the next button, this thing is enabled. So the CloudWatch and Lambda functions event driven approach is enabled, and it will start running each and every day. But do not do that if you want to keep your cloud cost low, because if you forget that, then this Lambda function keeps executing every day and that would incur a cost. I just wanted to explain you how this pattern works. So I hope you got a clear picture of how this entire thing works. And if you have any questions, do let me know in the comment section, but do not fail to perform this demo. It takes a lot of time for me to build these demos for you and explain. So if you do this and if you find this helpful, I'll be more than happy. That's all I have for today's video. If you haven't subscribed the channel, please subscribe the channel and share it with your friends and colleagues who are willing to learn AWS. Take care, everyone. See you in the next video. Bye bye.